Okay, so now that we've done a one-sided test and we've talked about a two-sided test, how do you know when you can use a two-sided test over a one-sided test? So I honestly, it's just reading the question. You have to read the question very carefully. If it doesn't say we want to test to see if the proportion of free throw shots is less than, the proportion of free throw shots is greater than, if it says something like it's different than, we're not sure if it's equal to, that's when it's going to be two-sided. We're going to use the wording of the question to determine if you want a one or two-sided test. So we're not using the data to determine if we want a one or two-sided test for the alternative. You make that decision before you actually gather your statistics. The wording to look for is we're checking to see if it's different than, will the result hold true, or just no direction whatsoever is specified in the question. So let's just take a look at this question. Go ahead and take a minute and read it, and then we'll take a look at the question and see how we can tell that there's no direction specified in the question. Okay, so let's take a look at the question here. So it says, should AJL and Associates do a more thorough investigation of this company at the alpha equals 0.05 level? Now, notice how in that question it just says, should they do a more thorough investigation? There's no direction specified in the question, so this is telling us, like, it doesn't say, is the number of expenses that begin with digit 1 greater than 30.1%? Is it less than? It doesn't give any direction. So since there's no direction specified whatsoever, we know we're going to use a two-sided test. All right, so let's set this up with our 7 steps. Hopefully you've got those 7 steps down by now. So remember, your stating is basically just like rewording the question. We want to see if there's a difference in the proportion of records that begin with the digits 1 at the alpha equals 0.05 level. Okay, the conditions and the assumptions. I always state the name of the test after the conditions and assumptions because then you know that your conditions are met to actually use that test. We plan to use a one sample z-test for proportions. Notice your simple random sample is in context. It's a simple random sample of 300 expense reports. The approximately normal condition, we are showing the numbers plugged in, showing that they're greater than 10 and stating that they're approximately normal. Okay, and then your independence condition, there's probably more likely than 3,000 expensive reports for the company. Then we're going to state our null alternative. Remember that you choose this before you even take your sample. So it's always, that's another reason to remember that it's always going to be in terms of the population and never in terms of the sample. So we believe that, or the population or the previously known belief is that the proportion is 31.1% or 0.301, and since we don't know if it's less than or greater than, we say not equal to, and it's not equal to 0.301. Now notice how the proportion is defined. P is the proportion of expenses that begin with the digit 1 for this company. All right, the do. Okay, once again, notice we have all the statistics here. Okay, notice how we have our p hat. This was our actually sample. 68 out of 300 had expense reports had that begin with the digit 1. Notice how we have 2 critical z-scores. Why do we have 2 critical z-scores here? All right, our alpha level is 0.05, so that means we're 95% of the time, think of this as the same as a confidence interval. 95% of the time we are rejecting the null, 95% of the time we're failing to reject the null, and 5% of the time we're rejecting it. But since it's two-sided, we have 2.5% above and 2.5% below. So that critical z-score of 1.96 comes from that area that's 2.5% below this point right here. So this is our cutoff region. We're rejecting. This is our fail to reject. Here's our rejection region. So notice this probability statement. There's 2 probability statements because it's two-sided. We're not sure what's the probability of getting that extreme. What's the probability of getting 0.2267 or higher? Okay, but since it's two-sided, what's the probability that I get 0.2267 or lower? Okay, what's the probability of both of them? Actually, that should be negative. Okay, so then what you're going to do is, this should actually be a negative because we're using symmetry, greater than, less than the negative. Okay, the z-score should be 0.2267. We're taking that minus what the population is, standard deviation here, and we get a critical z-score of negative 2.8506. Now, where is that? If we take a look at 1.96, all right, critical z-score is negative 2.86. That's below that critical z-score. So, because of symmetry, the two z-scores above and below are the same but with opposite signs. So we have the positive 2.8056 and the negative 2.0856. Okay? When we add those two probabilities together, we get 0.005. So what's the probability that it's greater than the positive and less than the negative? So you just have to take a look at when you get that z-score, you're going to say, okay, I know I have two probability statements. One is going to be greater than the positive, one is going to be less than the negative. So since I have the negative, that's the one that's going to be less than the negative, and then we know because of symmetry, my other one's going to be exactly the same. Okay, it's going to be greater than that particular number. All right, now there is sufficient evidence to show that there is a difference in the proportion of records that begin with the digit 1. If the true, here's our interpretation of our p-value, if the true proportion is 0.301, then the probability of getting a test statistic as extreme as ours is 0.005. Now we're going to link the probability to the alpha. So since p is less than alpha, this is statistically significant at the alpha is 0.05 level, and we reject the null. Okay, so we're going to do a quick review from section 7.1. And so just keep in mind, so we're taking everything we've learned and sort of putting it together. So let's take a look at this and talk about a type 1 error and a type 2 error, and let's describe these two in context. All right, so remember, what is the difference between a type 1 and a type 2 error? I always remember the type 2 error first because I think type 2, double F, we fail to reject the null when it's false. So therefore, a type 1 would be we reject the null when it's true. Okay, we reject the null. So type 1 means if we're rejecting the null, we say there is a difference, and therefore we pursue an investigation, but that in fact there is no fraud. That's rejecting the null when it is actually in fact true. Okay, the consequence would be that we have wasted time, money, and expenses. Remember, type 2 is failing to reject the null when it's false. So we're keeping the null, there is no difference, and we don't pursue an investigation, and in fact there is fraud. So the result is basically that someone gets away with fraud. And you have to decide like which one is actually worse. Now, I have been sort of talking about a little bit here when we're taking a look at these two-sided tests, sort of think about confidence intervals, and the middle portion is where you're failing to reject, and then the outside portions are where you're rejecting. So a confidence interval we can actually use to test a two-sided hypothesis. Now, you can use a confidence interval to decide between a two-sided hypothesis only, okay? Two-sided alternative hypothesis. If you use a confidence interval for a one-sided test, you will lose credit. Why? Think about the curves that you draw. With a confidence interval, 95% confidence in the middle, that's where we think the true population parameter is going to lie. We got these regions above and below where we're going to say, okay, if it, outside this confidence interval, my true population proportion is probably not there, but within two-sided alternative, it's the same thing. It's that middle portion, your confidence interval is like your fail to reject region, and those two portions on the outside are actually where we're rejecting them. What's the advantage of using a confidence interval over just a test of significance? Remember, a test of significance just says reject or fail to reject the null. A confidence interval not only tells us we can reject or fail to reject, but it also actually gives us sort of a parameter where the true parameter lies. So hypothesis, like I said, are just rejecting or fail to rejecting, but they don't give us any idea of where the new parameter could actually be, but a confidence interval will do that. What exactly is the link between a confidence interval and a two-sided test? The link between the confidence interval and the two-sided test is that the confidence interval gives a range of values that would not be rejected. Okay, so it's like I said, that middle portion of that curve is failed to be rejected. Anything outside that range of the values, basically too big or too small, is part of your rejection region, which is the same thing as a two-sided test. Outside of that middle portion, too big, too small, okay, we're in the rejection region. Okay, so the 95% confidence interval gives an approximate range of proportions that would not be rejected by a two-sided test at the alpha is 0.05 significance level. So 95% confidence interval, Okay, the 1 minus that is going to give your alpha region, but think about that, 95% confidence, that's the middle of your curve. 5% of the time it's going to be outside of that, so that's our rejection region. 5% alpha is the percent that we reject, so alpha is 5%, that's our rejection, that corresponds to your 95%. All right. So a two-sided significance test, say alpha is 0.05, and a 1 minus alpha confidence interval. So that's basically like saying if we're testing at 5%, take 1 minus 5%, and that gives you your confidence interval, 95% confidence interval. They're going to give similar information about the confidence interval. So let's just take a look and see how these sort of look the same. So notice, here's your 95% confidence interval. This is where the true population parameter would lie. Boom, outside of here, too big. Boom, outside of here, too small, we're rejecting. Okay, we're saying, oh, that doesn't fit in with the thing. Two-sided test, same thing. This is where we're rejecting, or sorry, this is where we're failing to reject. We're rejecting, we're rejecting. Okay, so same thing. Fail to reject, 95% of the confidence interval bounds. Outside of the bounds, we're rejecting it 2.5% of the time below and 2.5% of the time above. Okay, so when you reject the null, you might think to yourself, okay, so we're rejecting the null, but what actually is the true population proportion? So we're rejecting it, but if we don't know what the true population proportion is, it might not help us to get the further information that we need about the population. All right, so let's just take a look at our Benford's law and fraud example from the previous slide. Let's construct a confidence interval so that we have an idea of where that true proportion actually is. So we're going to construct and interpret a confidence interval for the true proportion of expenses that begin with the digit 1 for the company. Now, notice the directions here. This just says construct and interpret. We are not doing a test, okay, the 7-step test. We're literally, you have to be very careful with the directions. If we're testing using a confidence interval, we're going to follow those same 7 steps, okay, and then instead of using a z-score, we're going to use a confidence interval. In this case, it just says construct and interpret. That literally is just our state plan do conclude that we did in the past. That's no null, no alternative, because it doesn't say test, okay? All right, so here's your confidence interval. We've already stated that the conditions have been met, so we don't need to do that a second time. Here's our sample proportion. Your critical z-score, notice, remember here in your confidence interval, you're using this sample proportion, not the population proportion, because we're using our sample to estimate the population. So here is our range of values for the true proportion of expenses that begin with digit 1 for the company. So here's the interpretation. We're not, and notice this is not the same as a conclusion, so you want to be careful. This is just telling what that confidence interval means. We are 95% confident that the true population proportion of all expenses that begin with the digit 1 lies in this interval. If repeated many, many times, 95 out of 100 intervals would capture the true proportion. So just like I said, this is not a test. You're not coming up with a conclusion. This is just interpreting what that confidence interval says. Now, notice, look at the next set of directions. Use your interval to decide whether the company should be investigated for fraud. That is a test of significance, and that is using the conclusion, rejecting or failing to reject the null. Now, since we've already done the steps before it, we don't need to go through again and say, like, our state, what test are we using? What are the conditions? We've already met all of those. But if you were asked to do that, said use a confidence interval to decide whether this company should be investigated for fraud, you would have to do all 7 steps. All right, so let's take a look. Now, at our interval right here, should they be investigated for fraud? So this is where the true population parameter should lie. But let's take a look at our hypothesized value, 0.301. That's way outside of here. So if this is your fail to reject region, anything above or anything below is where we're rejecting. That 0.301 is definitely above the our fail to reject region. So it's actually, the interval is actually below this value. This value is above the actual interval. So this shows that there's strong evidence that there is a difference in the proportion of expenses that begin with the digit 1 for this company. So that's basically like saying we're failing to reject the null. All right, so like I said, I just want you to take a look at these 2 set of directions because students do get them mixed up. Construct and interpret a 95% confidence interval for the proportion of all expenses that begin with a digit 1. Now, what that means is you're going to do your state plan do conclude. State write the name of you're doing a confidence interval, you're going to do your 3 conditions, plug your numbers into the confidence interval, and then look at the instructions. We are 95% confident that the true population proportion of expenses. This is the interpretation. Do not use this interpretation for a hypothesis test. You will be marked wrong. Be very careful when looking at these directions, what they're asking you to do. This is the old thing, and then on the next video, we'll take a look and see what this means.